Hi everyone, my name is Yunus. I'm the president of ASTI and also advisor to the Young Inventors Challenge. I'm going to talk to you about problem identification. As you know, YIC is about invention. So you're supposed to come up with an invention to solve an issue or a problem that you see around you, which you feel strongly about. But it's very, very important before you start solving any problem that you should identify the problem correctly, because you do not want to be solving the wrong problem. Then there's no point even you going through the process of solving something, and then realize that that problem was never a problem in the first place, right? So we're going to talk about problem identification. This is the first step, the most important step that you have to take in your invention cycle as you invent a solution, right? So the purpose of this training, as I said before, is to introduce the issue of problem identification. Now these slides are going to be uploaded, so you can go through all the slides. So I'm not going to go through all the slides. I'm not going to read all of it in here. So I'm just going to go through very fast so that you get an idea of the module, this particular module. So make sure you, after you finish this training, that you download these slides and go through them on your own and kind of try to understand it as much as you can. So I'm going to introduce to you what's called a cognitive bias. And the reason why I'm doing that is because cognitive bias is one of the main reasons why we identify problems wrongly, right? So I'm going to read it now. This one, cognitive bias is a systematic mistake in your thinking, right? It occurs when people are processing or interpreting information. It normally causes us to make a wrong conclusion and thus results in a wrong action. So when you conclude wrongly, i.e. the problem, and then you go into the action. So you go through a study and then you come up with a conclusion, and then after that is the action point. But if your conclusion is wrong, then your action will also be wrong for obvious reasons. Although the action is correct in terms of the conclusion, but in terms of the things around you, it will be wrong because you have identified or you have concluded your study wrongly, right? So there are many types of biases. You got things like survivor bias, confirmation bias, belief bias, anchoring bias, bandwagon bias, and so on and so forth. So you can go through all of this. You just need to do cognitive bias. Go to Google or go to the internet and just type in biases, and you can read about all the different types of biases out there. So today we're only going to talk about one particular bias, which two biases. I'm just going to talk a little bit about two biases. One is called the survivor bias. Now, the survivor bias is illustrated in this particular issue that happened during World War II. So these planes, these are bomber planes that used to go out on their missions. And when they come back, of course, the people were shooting at them, and they were those that came back were heavily damaged, but a lot of them did not come back because a lot of them crashed. So when the engineers looked at this and they wanted to reduce the number of planes crashing, not coming back. So what they did was they looked at the planes that came back, and then they saw, as you can see in the picture, where the areas in which the most damages incurred. So you can see those red spots. Those, you imagine them to be like bullet this thing now. So these were where most of the damages occurred. So what they decided to do, or what they recommended to do, was to put an armor on where those red areas are. So that areas, when you put an armor, so even though people shoot at it, you won't have any, the damages will be minimized. So the reason why they want to do this is to make sure that more planes come home, right? That they don't crash. So it's the first conclusion that they made was that when the planes that came back those planes that came back, the red areas is where the most damage, right? And the second conclusion was by putting armors in those red areas, we would reduce the number of planes crashing. But that was a wrong conclusion and a mistake that they nearly did not make, because a statistician came and said, no, what your conclusion is wrong, because you're only looking at planes that came back. So what the real conclusion would have been is those places that you see red, where the shots were fired, I mean, they took a hit in those areas. Those are actually the safest areas. So those are the areas where the plane can get hit and still not crash. Because all the other places where the planes were hit, crashed, and they never came back, right? So what the real action that should be done is not to put where the most damages are, not to put the armor where the most damages are, but actually to put it where you don't see the damage. Because those that you do not see the damage, those were the ones that crashed, so they never came back, right? So this is an example of a cognitive bias. It's called the survivor bias. So if you want to know more about this, you can Google and find out what survivor bias is. And this is one of the classic example of identifying a problem wrongly, right? In which could cause to a wrong action. So your invention, so to speak, would be a wrong invention because you already identified the problem wrongly. So you said, by doing this, this will happen. But when you do this, that thing that you said you are solving is still not solved, right? So that's an example of identifying a problem wrongly due to survivor bias. The other one is confirmation bias. So this is one of the most common type of bias out there. And this, in a nutshell, so I'll let you read all this on your own. In a nutshell, confirmation bias is a bias caused by your own interpretation. So you may interpret things wrongly, right? So when you interpret things wrongly due to your own belief, because you believe that this is how things are, right? Even though that's not how things are, but you yourself believe that's how things are. So everything that you see out there, you will interpret it in a way that conforms to your own belief. So the example I gave you here was, let's say if you are a person who doesn't like dogs. So if you see a dog attacking a person, the first thing you say is, see, dogs are very dangerous. Or if you're a person that loves dogs, you would say that, hey, the guy was dangerous because he must have disturbed the dog, and that's why the dog is trying to defend itself, right? So which is right, which is wrong, we do not know. That is always determined by further studies. But our first reaction is always based on what we already believe, right? So our human tendency is to, confirm our own belief, because we like to confirm. Human beings don't like to be proven wrong. So we always try to say everything is right, because everything we see confirms what I already believe, and says whatever I say, which is whatever I say is always right. So that's an example of confirmation bias, and this one you can see in social media, especially in Facebook and all that. We always go towards or watch YouTube on things that we already believe in, right? And we see something in YouTube which we do not agree with, we'll always assume, or we always say that is wrong, just because we do not agree. Not because we do not care whether it's right or wrong, just because it's we do not agree, we say we do not agree with what the guy says, we say they are wrong, right? So just because you do not agree with someone doesn't mean that they are wrong and you are right. So keep that in mind. Then there's also an issue of perspective. Here's an example. This is an old Indian story about 10 monks who crossed the river. And when they crossed the river, the head monk asked the number of monks out there. So they counted, and they counted only 9. And then the head monk asked another person, and then the other person also counted 9. So everyone counted 9. So they thought they lost someone. Then they started looking for this person. And later they found somebody who was by the river washing some clothes, and then asked him. He said, "Hey, can you help us? We have lost one of our monks. There was 10 of us that crossed, but now there's only 9." So what happened was, this particular person that was washing clothes, he said, "Okay, let me count now." So he counted and he said, "No, there's 10 of you." Then he said, "What do you mean? We all of us counted only 9." That's when the head monk realized that the reason why they only counted 9 was the person that was counting did not count himself. So he was counting others, 1, 2, 3, 4, 5, 6, 7, 8, 9, forgetting to count himself. Right? Then that is why he always counted 9, and everyone counted 9. So they thought they lost someone, when actually all 10 had crossed. So this is an issue of perspective, and also how we collect data. Right? So this is very important when we are identifying a problem, right? So let's go to the next slide. Now, as I said before, the biases are the main reason for us identifying problems wrongly, right? So how do we solve problems better, right? I'm going to skip all this so that you guys can go through on your own. Right. Now, here are 6 steps that you take to identify a particular problem. Now, remember that this is just one way of looking at things, right? There are many other ways. So you can always look up on the internet and problem identification. So there are many different methods, very different things. So you go with one that you're most comfortable with. This is one of the ways in which you can go about identifying a problem in a very systematic way. So there are 6 actions here, right? So step 1, don't be fooled by large amounts of data, right? So most problems are complex, right? And there are many contributing factors. And data will help you solve the problem, but be careful of the data that you collect. Like, for example, the issue of the monk, did you collect it properly? You need to ask all these different kind of questions. Just because the data shows something doesn't mean that is right, because there are also other issues contributing to the problem, right? So you need to, including the way you collect your data. So be careful of that, be distinct of that. So one of the things, going back to the example, is to ask yourself question. So all scene data seems to show that the red spots are the most dangerous area, and therefore, so it shows that the red spots where the bullets were, those are the most dangerous area. But actually, what it really means is the red spots are the safest areas. So these are the areas where you can get shot and survive, right? So be careful of data. So how you collect your data and where you collect your data from. So these are some of the questions that you can ask, right? Step 2, dive below the surface to understand the problem, right? So understand the patterns, strands, systematic structures, and also your mental models. Remember, like cognitive bias and all that. Be very, very wary of your cognitive bias, your confirmation bias, so to speak. So be careful of those kind of things, right? So you can ask questions like, how was the data selected? How many planes are you examining? What are the planes type that you're examining, and all that kind of questions you can ask on step 2. Step 3 is widen your focus. So look at so whenever we identify a problem, we always look at one small area, which is, we have to do that because we can't solve the whole problem. But when you focus on one particular area, there's always many other contributing factors that contribute to this issue as well. So always look at the surrounding areas, the environment and stuff like that, right? So you may ask all the different type of questions like, do you have data for all the planes that left for the mission, right? Who are the pilots? Did you speak to the pilots? So you can ask these kind of questions, right, for this step. Step 4, define the boundaries of your problem carefully, because if you do not define your boundaries, you may end up solving too many problems, right? And there's a whole saying like that, when you try to solve the problem of the world, you end up solving no problem at all, right? You don't solve anything actually. So always remember that you must be focused in the problem that you're solving, and keep focused, right? Therefore, it's very important to define boundaries. So again, these are the kind of questions that you can ask. Of course, these are just some examples. There's all other different types of questions that you can also ask. Step 5, identify causes, effects, and key stakeholders, right? So this one is, now you're going even more wider. So, before you were looking at the problem as a problem, now you also want to look at like stakeholders, this problem is affecting who, right? And is this problem, I mean, you solve this problem, do they really want this problem to be solved? You're saying you're going and this community is having this problem, then you're trying to solve the problem for them. But are they really do they really see this as a problem? You may see it as a problem because of our own, confirmation bias, so to speak. But is it really a problem, right? So this are kind of, again, you can go through all this again, and again, these are the different types of questions you can ask. For example, have you spoken to the pilots? I mean, one of the most important things in the plane is the pilots, they are the one that are putting their life in danger, right? So you need to talk to them and ask them, look, what is the problem really, right? So on and so forth. And then now we go to the final one, analyze future developments. So keep in mind that you may be solving this problem. And in today's world, a problem that you solve today could be solved by someone else in a better way, right? So always keep that in mind. Look at the new technologies that are out there, new way of thinking that are out there and all that. And keep that in mind whenever you come in an invention or whenever you're identifying a problem. Because a problem today can be a problem, and tomorrow the problem itself will no longer be a problem, will no longer be viewed as a problem, right? Okay. So again, these are the kind of questions that you can ask. So this is only one example of problem identification. Again, not all steps. So we went through the 6 steps. Not all doesn't mean that you have to go through all the 6 steps. I've forgotten 4th step and all that. Maybe your invention, one of the steps may not be as relevant as the other steps. So again, these are all rules which are not set in stone, right? These are only guidelines for you when you are identifying the problem. But what is very important is always ask questions. Always push yourself and ask questions whether or not you identify the problem correctly, and so on and so forth. And going on from there, you must remember that we like to solve problems, but we must also be wary of us, because we are the problem solver, problem identifier, and problem solver. So there are a lot of most people who solve problems, they have good intentions, but there are some people who are not good people also who claim that they solve problems. For example, Hitler during World War II claimed that he was solving a problem, but actually no, he was creating a bigger problem than what he claimed to solve. So always keep in mind when you are solving, when you are identifying a problem and then solving, always be humble, be compassionate, and have empathy. Empathy means you feel for the other person. As I say, treat your neighbor as you like to be treated yourself. So that's an example of empathy. So always be empathetic. And most importantly, when you identify a problem and later you found that you have identified it wrongly, be patient, go back to the problem again and analyze it again to make sure that you have identified the problem correctly. And one of the ways you know that you may have identified the problem wrongly is after you come up with an invention or you come up with a particular action, you do the action and the problem is still not solved. So if the problem is not solved, it could be 2 things. One is your solution is wrong, or your identification of your problem was wrong. So you can always go back and then look at this thing, and this would require a lot of patience and time. So you need to be patient, and you need to persevere. Don't give up. It's very, very important, right? So before we end, right? The issue of problem identification, problem solving, and all that means that you will be thinking out of the box. And it's very important whenever you think out of the box, you are, in a way, you are alone. You are different from the rest, right? So some people may call you crazy or unrealistic and stuff like that. So whatever happens, people make fun of you or whatever, you must always persevere, and keep pushing ahead. An example of crazy people, people who were called crazy during their time was people like Christopher Columbus, who helped find America. And then you got the what do you call Bruno, who previously they said the Earth was the center of the universe, and Giordano Bruno was an astronomer, and he says no, actually Earth is not the center of the universe. So there are many things around the universe, and Earth is definitely not the center, right? And obviously a lot of people hated him for that at that time. And then the Wright brothers were also called crazy because they believed that people can fly. And if they gave up after a lot of people making fun of them, we would never have airplanes today, or we may not have airplanes today. Right? Vesalius Sola. So I'll let you go through all of this on your own. Galileo Galilei. Galileo Galilei is one would consider one of the greatest inventors and scientists of all time, who invented the telescope, and people also called him crazy, and he was thrown in prison for saying that the Earth rotates around the sun. So again, he did not give up, although a lot of people were making fun of him or putting him in prison. He kept to his belief system. Right. So with that, I think we've come to a conclusion of our training today, or at least my training today, on problem identification. If you have any questions or any suggestions and whatnot to us, please do email us or call us at the address that you see that in the slide. So I'd like to thank you all. Good luck with your inventing. And again, as every year, we've always been very, very amazed with the inventions that you guys have come up with. And the committee and myself are very much looking forward to seeing your inventions. And I'm telling this to you early. This is a process. We are the inventors program. We are concerned more about you than your invention. So we like to create inventors. For us, the invention is not important. You are the one who's the most important, because we are creating inventors and not invention. So good luck, guys, and we see you soon at the next event. Thank you. Bye.